Well, once again, hi, my name is Dr. Maldonado. I work in the research division. I would manage this contract for the project that Tom Durbin is going to be describing. For those attending by webcast, I'd like to welcome you to this presentation. And if you'd like to send me email questions or comments, the address is Sierra Room, it's SIERARM at calepa.ca.gov. And you can send questions and we'll answer them at the end of Tom's presentation. And I'd like to introduce Tom Durbin, who is an associate research engineer in the Emissions and Fuels Research Group at CE-CERT. Dr. Durbin conducts research in a broad range of topics related to vehicle emissions, including particulate matter measurements, diesel, biodiesel, gasoline fuels, portable emission measurement systems, and unregulated species such as ammonia, nitrous oxide, and toxics. Dr. Durbin conducts research in CE-CERT's state-of-the-art emissions test facilities, including heavy-duty vehicle emissions laboratory, heavy-duty engine dynamometer, and light-duty chassis dynamometer. Dr. Durbin is also extensively involved in in-field measurements of emissions from passenger cars, heavy-duty trucks, and construction equipment. Prior to joining the Emissions and Fuel Group, Dr. Durbin was involved in several other areas of research at CE-CERT, including renewable energy and fuel sources and advanced vehicle technologies. Dr. Durbin received his doctorate degree in physics from the University of California, Riverside in 1994, where the primary focus of his dissertation was the study of SI films and solid lubricants. So, without further ado, Tom Durbin.
Okay, thanks, Hector. All right, so I'm going to talk to you about a project that I've conducted part of it. The earlier part of this program was actually conducted by a couple of other folks, and so the author list includes some of the folks that worked on the earlier part of the project, as well as some of us that were more involved later. And the objective was to look at the incidence of malfunction and tampering, but also try to better understand the in-use emissions from heavy-duty diesel trucks. Okay, the motivation of the project was essentially to look at an area that wasn't going to be targeted by the current regulations, or the regulations that were going to be dealing with emissions from the newer vehicles. This program was targeted at the in-use emissions, the fact that there is potential for tampering, as well as deterioration of those vehicles. And ARB does have some programs that can deal with that, but a lot of them are more smoke related, as well as instead of more comprehensive programs. So the idea was to understand these emissions and see if there were other ways that could be used to implement programs to look at in-use emissions. So one of the programs that was conducted prior to this was called the Measure 17 program, and that was just a program where they looked at a fleet of about 109 vehicles. This kind of followed up on that and expanded on what was being done there. Okay, at the time of this project, and I'm not going to tell anybody when it actually started, so but it did start back in the Impact 2000 era. So these plots here are from Impact 2000, and they just kind of show what we would want to target, and it's pretty obvious. It's basically the Class 8 type of vehicles that we're going to be looking at in terms of the NOx emissions. Okay, this is again an old school breakdown here of emissions by model year, and what you can see here is that if you look at the break in the emissions, about 80% of those emissions were from the year 1988 and beyond. So as we could, we were trying to target that particular area, although the study sort of hit a pretty broad range of vehicle categories. So the project itself, we're going to look at two somewhat separate elements, both geared at understanding in-use emissions and maintenance and issues that can affect in-use emissions. The first segment is essentially to review data records and get an idea of how the tampering rates from a variety of different sources would compare to those that are currently in IMFAC or that are currently being used by ARB at the time. The second segment of the program was essentially an in-use testing program where we grabbed a couple of vehicles off the road and from rental car agencies, took them on a course, and we looked at what their emission rates were over varying types of operation. Okay, so the first part of the program was in fact the kind of the paper study part of the program. We looked at a number of different sources to try to better understand tampering and malmaintenance records. Part of it was a literature review. We looked at some of the visual inspections that ARB was doing in their surveillance programs. We looked at warranty records, independent shop records, and we did also some separate studies of ourselves where we were essentially looking at roadside surveys at truck stops. Okay, the first part of the program, we focused mostly on the literature, and essentially from the literature we identified two studies. One was Radian and one was from Engineering Fuels, and I can't remember exactly what it's Chris Weaver's group, so for those of you that are familiar with that. And from the slide you can see that there's a relatively reasonable comparison between these two studies, and these studies were part of the basis of what was used for the IMFAC rates in these different target areas. So while we did identify these two studies that were already being used in IMFAC, there was not a lot of other data out there that we found that could be put into the queue in terms of this type of information. So we did also look at some website information, and again, some of that information would give us a hint as to what might be a malfunctioning component, but in terms of the actual rates, there was not a lot there. This next slide just kind of shows you where IMFAC was at that time and compared to what the revised emission rates were. And you can see a lot of the categories line up fairly similar with those two studies from the literature review, although there are some slight differences both from the literature review as well as in moving from IMFAC 2002 to the IMFAC 2007. Okay, one of the first sources that we looked at separate from the literature review was the heavy-duty vehicle inspection program that ARB carries out. So there was a subset of about 5,200 records that were available for us to look at from this particular program. Now the records themselves span the calendar years 1998 to 2002. So in terms of looking at the calendar years, just below you can see that we had a number of records in each of those calendar years. Now that doesn't represent the model year of the vehicles that are being looked at. That's simply the number of records that were collected in any particular calendar year under this particular program. So the one aspect about this particular program that's important to point out is the fact that the inspectors, their goal is to pull over vehicles that might be suspect. So it certainly is a biased data set in terms of what we might be getting out in terms of the rates itself. And at the bottom of this slide essentially shows what the model year distribution of these vehicles is. And you can see compared to what was a 1998 database, it's certainly biased toward the older model years. So we just kind of have to keep that in mind when we look at this data. Okay, the data itself was separated out into a number of different categories, but there wasn't the depth to do the full 19 categories or so that you saw on the previous slide. And generally what you see if you look down at the rates themselves, and let me see if I can get my laser pointer here. In in many of these cases, actually, you see that the rates where things were modified or missing was actually fairly low. So I guess that's, if you're an A or B person, you'd consider that to be a good thing. So there didn't seem to be, at least from this particular data set, a lot of problems that were at least visually observable in the field. Okay, the second set of data is a set of data that was essentially from warranty claims for the different engine manufacturers. So the warranty claims come about at a point where there's greater than an incidence of 1%, or for certain model years it could be 25 engines in a particular family. Depends on what the population is for that. So again, this comparison basically shows the results of this breakdown compared to the EEFE study that was done, that's kind of used as the basis for MFAC. And you can see in a number of cases there's fairly low incident rates in terms of the values that we got. On the other hand, there's a couple that really stick out as being sort of high incident rates compared to those that were found in the earlier study. There's a couple of potential reasons that this could be. The database, at least from what I understand, this was done earlier prior to me, there is a possibility that you can double count these incidents if, for example, a truck comes in multiple times. So there are probably some issues in here that drive this rate up a little bit higher than what you would expect. And these data are also normalized to DMV registration rates as opposed to sales records for particular years. Okay, the second source we're looking at here, and again, it's probably got a little bit of a bias here, is basically a repair facility. And all of this data was collected from a single repair facility. It was about 500 records that were collected. I think it was over a period of about 1 month. And essentially, all of the vehicles that went through this repair shop during that 1 month period were essentially logged and identified as to what problems they might have or not. So some of those vehicles would have been coming in for routine maintenance. Some of the vehicles, on the other hand, would obviously be coming in for a specific problem, and you would probably see a higher rate because of that. So in comparison with the earlier study, interestingly enough, even though you might expect higher rates of incidence for this repair facility, we did not actually see a lot of categories where this was happening. A few down at the bottom were the mechanical failures and oil consumption, but in general, it was fairly comparable. So perhaps that might even lead one to conclude that the earlier rates may have been a little bit too high, given that this was not a fully random sample. Okay, the third study or the third portion of the study that we did was essentially we looked at picking out drivers from a truck stop, or I think it's the facility down in Temecula, and essentially we just pulled them over and did a roadside survey. So this would essentially be a random study, and we had asked them a variety of different questions, and one of for this particular graph, the main point was how many incidents did you have, or did you experience any incidences in these particular categories over the past 12 months. So the results of this study, again, are fairly comparable to those from the earlier study, especially considering we've got 58 records, so it's a relatively small sample size. And in some cases, a little bit, maybe a little bit lower in terms of what the rates were. Okay, in conjunction with this roadside pullover study that we did at the Temecula stop, we also looked at doing some ECM downloads for a subset of the vehicles. So we did a subset of vehicles, a subset of 7 vehicles for this particular sort of screening study, and all of these vehicles were actually Caterpillars because that was the manufacturer that we had the software for. And the idea was basically to read the ECM and see if anything had been installed or somehow the engine was operating in a non-standard manner or something outside of the range that would be a factory setting. So of the 7 vehicles, we found that the 6 hadn't been changed at all, and 1 had been changed but to a factory setting. So there was no suspect problems that we found there. They were all operating within the factory settings. So in addition to sort of the inspection part of this program, we were also able to download some other information, including the speed distribution. So at the bottom, the chart basically shows the speed distribution for one of the 7 vehicles that was tested. And the speed basically at the bottom is broken down in miles per hour. And more so interesting than anything else is the fact that there is this resource available that you can go and get some information that can give you an idea of what the activity is of heavy-duty vehicles as they travel on the road. Okay, so some of the conclusions from this initial portion of the study. In total, over all of the different records that we looked at, it was about 7,000 records. The warranty repair incidences were comparable to what we found in MFACT, with the exception of a couple of different categories. And again, those categories may have been high for reasons that, we just didn't have a great enough control of the data set at the time. The visual inspections did show some signs of tampering, but it wasn't really a very high level, less than 1% for a lot of the different categories. Let's hear the roadside pullover. Again, we found certainly the results were in the ballpark of impact, and also even the facility repair records were comparable to what were in impact. Now, I guess one could also make an argument that if some of these data sets are a little bit biased on the high end, maybe that impact is a little bit high, but I'm not sure exactly how they implemented this data into impact. So at the conclusion of the study, there was, the conclusion that they reached in terms of doing more work or doing less work in this area. The decision was made that in terms of improving the impact tampering rates, probably there was not a lot of additional information that could be had to, at least from these type of techniques, that would be of significant value. Okay, the second part of the program is the in-use emissions testing. So this testing was done up in Stockton, California, on a fleet of 5 different Class 8 heavy-duty vehicles. They varied from 96 to 2004 with the different engine manufacturers. The testing itself was conducted with the CE-CERT mobile emissions laboratory, which I'm going to show you in another couple slides. And the testing itself was done not on a chassis dynamometer. It was actually done on the road over a road course that characterized a variety of different operating conditions, including highway crews, low-speed crews, surface streets, and other things called power lugs. So the test fleet is as shown here. You can see we got each of the major engine manufacturers, Cummins, Caterpillar, and Detroit, as well as Mack, and different chassis, but a pretty diverse range of odometer models in terms of what the fleet size was there. And some of these were coming basically from rental cars or rental agencies, so they were a little bit newer. So it's a pretty wide span, and maybe not as many as you'd like, but enough to find at least a few interesting things. So the test route here is shown. It's based out of Stockton and the ARB's emissions testing facility there. You can see it's shown in the lower right-hand corner of the diagram, and then the 4 segments that were followed are essentially shown in the square that surrounds the top of the graph. So the first segment was basically freeway driving on Highway 99. Then essentially we got off with the trailer and did surface street driving over to the 5, came down the 5 for about the same amount of miles, and then went back over for some additional surface street driving. Okay, the mobile emissions laboratory, for those of you that haven't seen this facility or haven't been exposed to this facility, essentially it's a full-scale dilution system that's put in the back of a trailer. So you can see that right here, this is the input to the trailer. So it essentially collects emissions from the exhaust of a Class 8 truck as it's pulling the trailer around to measure the emissions. So the front here corresponds to the front of the truck, which is in the upper right-hand corner of the second graph. And then the dilution system runs right along here, and the intake air comes in at the bottom of the graph. So it's a fairly flexible facility. It's got a flow rate that goes up to about 4,000 CFM, and essentially we've gone through a 1065 audit with this facility, and we've also cross-correlated this facility with ARB's laboratories down in MTA, as well as Southwest Research, and we found some pretty good correlation. We've also done some correlation with the Stockton facility with this apparatus, but it's fairly versatile. We can use it with engine testing. We can use it with on-road testing, and we do a lot of testing with backup generators too with this. This is just a schematic of the system again, and again, right in here, this is our particulate sampling, so we can do a lot of different variety of particulate sampling. This is the gas analyzers, and back here is sort of the pump and the auxiliary stuff. Okay, so the first graph I'm going to show you is the NOx emissions, and over in the left-hand corner of the graph, these are essentially the impact values that you would expect at a particular range of speeds for these particular vehicles. So essentially we took the base emission factor from MFACT, which is derived at about 20 miles per hour. We looked at the model year of the vehicle and added in its mileage so that the MFACT emission factor corresponds with the specific vehicle that we tested here. So obviously MFACT is an aggregate model. We don't expect the correlation between a single vehicle and the model to be perfect. We just want to put that in as a comparison. So over on the right-hand side are these power lug events. And you can just, glancing at them, you can tell they're different. Essentially, they're not designed to be a real-world driving event. They were designed to be an event that potentially could be utilized at the Stockton facility for a maintenance type of program. So essentially, the power lug was done by taking the vehicle to its highest speed and then applying the brake to provide some form of loading on it. So again, it's somewhat of an artificial cycle. Okay, so if you look at the data, it's arranged from the oldest to the newest vehicles and over the different driving conditions. So the two freeway driving segments are the 99 and then the 5, and then the surface street driving are essentially here and here. So looking at these data, looking high to low in terms of, or old to new, generally they show that the NOx emissions on a gram per mile basis were highest for the older vehicles and decreased for most of the driving conditions for the newer model years. So I guess that's a good thing. So in comparison with MFAC, in a lot of cases, you can actually see that the emission factors that we actually found on the road were less than what were found in MFAC. So that was an interesting conclusion. But this is not necessarily the case in all cases. For example, the 96 vehicle did show some places where it did have higher emissions. So, and also in terms of trends, we did see in some cases some of the vehicles, for example, the newer vehicles, a lot of them had similar emission rates on a gram per mile basis over the different range of driving cycles. Others, for example, the older vehicle, we did see trends where there were higher emissions on the highway compared to what we found on the surface streets. Okay, just looking at the same data set in a little bit different manner. Here we divided the emissions by the fuel use so that you can get a sort of some idea of what the emission rates were as a function of the work or energy expenditure. And sort of over on the right-hand side of the graph, you can see that the big thing that does is that takes these power lug elements down to where they're comparable to what the normal surface street and highway driving is. Other than that, you see there's some trends in the data that still exist. Still generally see this trend where the older vehicles have the higher emission rates, and also you can see that for the highway cycles, the older truck here did have a higher emission rate even when you take into account its fuel use. Okay, particulate emissions. Again, we're looking at the MFAC base factors on the left-hand side of the graph. The base factor itself would be approximately 20 miles an hour, and then the 55 would correspond to the cruise section. So for particulate emissions, we only measured two segments of driving. In particular, the driving on Highway 99, which was done under cruise conditions, and then surface streets driving on Hammer Road, which is the final segment of the in-use testing. So if you look at the values here, and again to make the comparison with MFAC, these two are comparable, and then the Hammer Road is comparable with the base factor. In both cases, we found that the in-use emission rates were generally lower than what we found with the MFAC model, and that was true for essentially almost all of the trucks that we tested for this subset. Looking at the highway cruise right here, we saw a somewhat interesting trend in that the two later model year vehicles actually had higher emission rates than the three earlier model truck years. So little bit of a surprise there. And in order to kind of understand that a little bit better, if we go over to the far right-hand side of the graph, you can look at the NOx emissions, and the corresponding NOx emissions for the cruise on the 99 show quite a bit lower NOx emissions for these two particular model years, or for the two newest vehicles. So at least for this particular type of driving, it looks like there might be some kind of NOx PM trade-off that's going on. If we go to the surface streets, we see something a little bit different. We see that the older vehicles here tend to have higher particulate emissions, which might be closer to what we might expect. And also, in comparing the PM and the NOx emissions, we don't see sort of this trade-off between the NOx and the PM emissions that we saw at the cruise conditions. And then finally, in terms of looking at comparing the vehicles over the different driving conditions, you'll see that the cruise versus the surface streets, there wasn't a lot of difference for the newer model years, but for the older model years, we did see significantly higher emission rates on the surface streets as opposed to the highway cruise conditions. Okay, for the PM emissions, again, we also did fuel-specific PM emissions for this study. And if you look on the left side of the graph, you can see that for the highway conditions, the fuel-specific emissions were fairly comparable to what we saw in the strict grams per mile. The two newest vehicles also essentially had considerably higher emission rates than the older vehicles under those conditions. For the surface street conditions on Hammer Road, we found essentially similar results as we did for the grams per mile, just a little bit closer in terms of the comparison between the newer and the older vehicles. Not quite as big a differences. Okay, for the hydrocarbon emissions, here we kind of had quite a variety of, quite a range of different effects here, since hydrocarbons tend to be less significant from an emissions control standpoint. So let's see here. In comparison with MFAC, there was a variety of different conditions. In some places we found that the emission rates were higher than those from MFAC. In some cases we found that they were lower. So if you look at the sort of the body of information that's about the 40 mile per hour cruise, maybe some of the surface street driving, depending on what vehicle it was, we generally found higher emissions were occurring under those conditions. On the other hand, if we're comparing with MFAC, the O2 and the O3 in particular generally had lower emission rates than what was found in MFAC. So sort of a mixed bag in terms of how things compared with MFAC in this particular study. Okay, CO emissions. Again, CO emissions tend to be of less importance for heavy-duty vehicles. So here we primarily see that for the surface street conditions, either on Hammer Road or where we did these 40 mile per hour cruises, that was where the CO emissions tended to be slightly higher. In general, they were fairly low. And if you look at just the highway driving itself, they were on the order of 1 to 3 grams per mile. So not very high emission rates for the trucks as you might expect. The power lugs, again, a little bit unrealistic, so we're seeing some higher emission rates there. And in general, the emission rates followed this trend where we're seeing higher emissions at the lower speeds and decreasing emissions at the higher speeds. So they tended to follow the trend that was seen in MFAC, and roughly the comparison between what was seen in MFAC and what was seen on road was fairly reasonable. Okay, this is just one example of the real-time emissions that we saw. And in terms of the segments, this first segment here would be the driving on the I-99. This next segment here is the second or the first of the surface street patterns. This third hill here is the driving on the I-5, and then finally all of the remaining data is what was collected on Hammer Road. So it was a little bit more transient. Here you can see a couple of different bumps. That just means that we're testing out different speeds in terms of the cruise level that we're using. And also you can see that there are some transient spikes even on these cruise events, and that's partly due to the fact that there's cruise control on and they're adjusting based on varying dips in the road and such, or elevation changes and whatnot. So that's kind of what the emission rates look like when they're on a real-time scale. Okay, and finally, just conclusions for this part of the presentation. If we look overall at the data, there's a lot of differences depending on what type of driving conditions the vehicles were under, what specifically the pollutant was, and also what vehicle we were testing at the time. The real-time emissions, as you might expect, were transient and pretty dependent on the engine operation. For the NOx emissions, we saw a general trend that the older vehicles had higher emission rates as opposed to the new vehicles, and we also found that for some of the vehicles there were higher NOx emissions under the freeway speeds, but that wasn't the case for all of the vehicles. Okay, for PM, the surface street driving and the highway driving, we saw some different trends. For the highway driving, we found that the newest vehicles actually had the highest emission rates for particulates, and part of that was due to part of that we could attribute to a NOx PM trade-off. For the surface street driving, the older vehicles had the higher emission rates, and those emission rates for the older vehicles were also a lot higher for the surface streets compared to them driving on the highway. THC emissions, they were generally higher for the lower speeds, either at the surface streets or for the 40 mile per hour cruise compared to the highway driving. And finally, for CO emissions, they were generally pretty low if we were looking at any of the steady state driving conditions or the highway driving, and a little bit higher for the surface streets. So, and that's it. Are those the email questions?
A couple questions for Tom. One is from Tom Dodington, our deep grant. Two questions. One is from Tom Dardington, who's always anxious to second guess our work. And the other is from Lee Zhu, who works in our offices. Okay.
Actually, I talked to Tom earlier this week, so. Okay, the first question is from Tom Darlington. Do you consider the warranty data to be a random sample of the fleet? If not, what bias do you think the warranty data has in terms of determining the frequency of tampering and malmaintenance? In terms of the data set for the warranty, essentially, from what I understand, the incidence rates from the warranty were divided by the registration rates from the DMV database. So one bias I would think is that you might want to take the warranty data and divide it instead by the sales figures, although there's probably some complications in going from California versus other areas of the country. So that's one potential issue that I would see in the database for the warranty data. And also there were certainly some high numbers there that to me didn't seem to be real. So I think part of that may be in the development of the database. There's some things that we couldn't pull out in terms of perhaps double records on certain things or other issues. So those would be some of the caveats I would put for the warranty data. So, okay, and Lee Zhu from El Monte, 2 comments. The cited emission rates from MFACT are all on the basis of federal pre-controlled diesel. So if the UCR tests were done using California low sulfur diesel, the MFACT numbers should be corrected in order for the comparison to be done on the same basis. The impact is about 25% for PM, 7% for NOx, and 28% for hydrocarbons. So again, I'll note that as sometimes we see more or less differences between California and federal fuel, but this is, I guess, what ARB considers to be the basis. So let's see here. And then the second question she had was, as observed from the CRC E5559 and New York test data, emission rates of heavy-duty diesel trucks tend to show large variability within the same model year. The emission rates used in MFACTs are average emission rates of 2 or more model years. Therefore, it may be useful to plot each of the UCR data together with data from the same model years that were used to estimate the MFACT emission rates. This will show whether the UCR tests were within the data ranges of the MFACT data set. So that's a good comment, and perhaps I can follow up with that and get some of that information from you for maybe for the paper we're hoping to publish on this.
On slide 17, you listed the trucks, their model year, and their odometer reading. And the 2000 Caterpillar had an odometer reading of 18,000 miles, which seems rather low. Were you comfortable with that? Did you have an explanation for that low mileage compared to the other trucks?
That's the CE-CERT truck. So we like to baby it a little bit. Still representative. We haven't played with it or done anything fun.
Tom, thanks for a good presentation. So overall, what is the bottom line of your study? What is your interpretation of the findings? Is there sufficient information to suggest that there's a need for an I&M program for heavy-duty vehicles, or you concluded that MFACT is doing a good job predicting? Do you think that you want to go beyond that?
Or maybe we concluded that we weren't going to be able to improve impact any. So it's hard to say. That particular portion I was not involved with, so I'm somewhat familiar with that information, but not fully familiar. Some of the things, there were a couple of things that did stand out as being high, but I wasn't convinced in sort of reading through the report and preparing for this that those were necessarily problem issues. They may have been something in the database that we just couldn't ferret out. So there were some incidences, but I don't know. I'm not going to make that political. I don't want to make too many political judgments based on that. And in fact, some of the data sources you might say that MFACT was overestimating, because we were taking some databases that would be biased high, and in fact, we were finding rates that were comparable to those in MFACT. So yeah, I think certainly there's a need to understand this issue better. I'm not sure if the methodologies used here or if other methodologies would be the best way to go about that.
Did you collect data relating to idle emissions at idle as part of this study?
No, we didn't for the trucks that we have some other studies where we've done that, but not for this particular study. And while we're waiting on the question, just the two segments of this study, there are published reports on both of those. So if anyone either in the audience or on the webcast is interested, I can get those results to you so that you can look at them.
Okay, thanks. You mentioned tampering and malmaintenance factors in MFAC. Where did those originally come from? And then another question was, you said you saw visible tampering in something less than 1% of the time. Mm-hmm. What mainly were people doing to their trucks, and physically, what were they doing and why were they doing it?
Let's hear. For the, let me go. My understanding on the impact rates was that they were largely derived from the two studies that we identified in the literature, the Radian and the EFEE studies. So my understanding is that these studies still probably had a large influence on what's going on in impact. But I also understand that they may have brought in some information on warranty repairs. And Hector, did you get a chance to talk with anybody about that? No? Okay. Yeah. Let's hear. What was your second question again? Sorry. Physically, what were people doing? I believe it was visual inspections and maybe just a few things where they were poking around.
When truckers, bless you, when truckers were tampering with their trucks, what were they physically changing, and why did they do it? Was it for fuel economy or?
That's actually, I think I might have an expert in the audience that can answer that question for me.
My name's Don Chernick with the Resources Board. As far as tampering goes on these trucks, there's a lot of varieties. Some of it is fuel economy. A lot of it is power related. They want to have more power for when they're driving their trucks, depending on the application. The tampering, I think, is probably less. We don't see it as often in the field with electronic trucks. But overfueling, I noticed that you noted that overfueling was somewhat frequent, and that's generally trying to get more power out of the vehicles.
Yeah, do you run those vehicles on a multiple number of paths to get the average emission factor out of it? Or?
Each one was run, I think it may have been once or twice. I think it was a couple times on the paths. So it was more than once, but it wasn't 10 times. It was 2, maybe in some cases 3.